Experiment 14. Potentiometric titration and determination of pH by Kinhidron electrodes. This experiment consists of two parts. First, potentiometric titration. The purpose of this experiment to determine the turning point of the reaction in the cell by measuring the electromotor force of galvanic cell composed of a reference and an indicator electrode. Chemicals. Solution of solid iron, ammonium sulfate, salt in sulfuric acid, potassium bichromate, saturated potassium chloride solution, and saturated solution of the Kinhidron in water. Materials: potentiometer, reference electrode, indicator electrode, salt bridge, bear glass, and burette. The cell schema and redox reaction of the experiment are shown in figure. Here, the iron ions are oxidized with the help of the chromate. Before starting the experiment, iron solution is diluted with distilled water at the ratio of the 5:1 in 50 ml beaker. On the other hand, the chromate solution is put into the burette. Then the reference and indicator electrode connections are made. The potentiometer device is switched on. Potential is read before chromate is added. The value read from the potentiometer 420. By adding 1 ml of chromate by the burette to the iron solution, the solution is homogenized with the help of the drumstick for mix, and the potential is read. You should wait 1 or 2 minutes between each reading. After adding 1 ml, the potential is read and noted. Half milliliter of chromate should be added as it approaches the turning point to avoid the turning point. For 1 milliliter is 430 and 33 433 for 2 milliliter, and 2.5 milliliter for 2.5 milliliter is 446. The same as 3 milliliter is 453 millivolts. In the same way, the value read from the potentiometer for 4 milliliter is 476, and for 4.5 milliliter is 512, and the last one for 7 milliliter the value read from the potentiometer is 670. It was noted as 670 millivolts, and after turning point 1 milliliter of chromate should be added, not half anymore. Using this data, you have to draw 3 different graphs derived from each other to find the turning point. These: first, volume of the chromate reacted added against potential. 2, first derive. 3, and the second derivative. Okay? And 3 different graphs should be drawn for the sensitivity of this method. The second derivative curves will exactly determine the turning point. The deriving of the first and second derivative curves is given in your experiment sheet. The values obtained are given in table shape on the last slide you can see. Our first experiment is done. Now let's go to the other experiments. The second part of the experiment is determination of the pH with Kinhidron electrodes. Here, the purpose is to measure the solution pH with the Kinhidron electrodes, whose electrode potential is dependent on hydrogen ion activity. The reduction half equation for the dissolution of Kinhidron in water is shown in the figure. When Kinhidron dissolved in water, equal amounts of quinone and hydroquinone are produced. The solution whose pH is to be determined is saturated with Kinhidron, and the platinum electrode is immersed and connected to the reference electrode with the help of the salt bridge. The potential and the temperature of the resulting system are read and noted at the same time. Make comments by calculating the pH of the solution with the help of the next equation using the temperature and the potential data in your report. Thank you for listening. Temperature and electromotor force has been given at last.